Thanks, everyone, for attending my talk. I won't have as many jokes as my last old colleagues had about Tinder and things like that, but hopefully you'll enjoy the talk. So who am I? I was previously a systems engineer at Cloudera. I worked with Mark Rover, who was giving the last talk. I was there for a few years. I've worked on a lot of these big data platforms, and so hopefully give you guys some tips and tricks that I've learned along the way for deploying Apache Spark. I have a pretty deep knowledge of the big data stack, including HBase, HDFS, Hadoop, Yarn, and all these other deployment models. I do work at Databricks. I'm an Apache Spark expert there. I'm a solutions architect who helps customers get onboarded with our platform and also understanding our architecture and deploying in a cloud environment. So what will you guys learn today? Hopefully a quick overview of Spark, 1 or 2 slides just for people who don't know, the configuration systems, pipeline best practices, and some debugging techniques. There will also be a slide to go over some common mistakes or maybe some common features that people aren't leveraging today that will help you improve the efficiencies of your jobs. So what is Apache Spark, if you don't know by now? Well, this is a diagram of a simplified diagram of what Apache Spark is. There's a driver program. That's where you're writing all your code. It's going to break that code into a bunch of tasks. It's going to serialize that and push that out to a bunch of worker nodes. And the reason you're doing this is to get away from this single machine processing systems that a lot of people were used to and distribute a lot of the workloads out. You know, as data has grown tremendously over the years, you really need a distributed platform to do a lot of the work. What did the configuration subsystems look like today? When Spark was just released, it was the Spark core APIs. We've added a lot of new features such as SparkSQL, data frames, streaming, machine learning, and GraphX. And GraphFrames is going to replace GraphX there shortly. But with each one of these systems, they have their own specific configurations, and we'll talk about them in this next slide. Spark was built with Hadoop as a dependency, so there's also some Hadoop-related configs as well that you will need. And so configuring these environments does get complex. There's a few configurations that are done at the command line when you're spinning up your clusters. If you're using Yarn, you're going to set some of these. A few of them are environment configs, that spark end.sh. That's where you're going to set maybe the Python library path for your PySpark jobs, your executor sizes, and those things. Spark defaults those are where you're going to set the Spark-specific configs. You can do this programmatically within your API when you're writing your Scala code. There's a Spark conf object that you can instantiate and put in all your configs there. And then there's also some Hadoop site configs. If you're using a platform that some DevOps team has set you up with and you're looking to optimize your job and you want to know what the system looks like, and maybe you don't know where to look, in your job you can actually print it out. There's some nice debug APIs where you can print out all those configurations and take a look. It's a huge list. There's a lot of configs. The ones that are set by default might not be there, but sorry. You can use these little strings to take a look at those configurations to actually see what your system is deploying, because your DevOps team might be setting some defaults for you already, and it'd be good to know what those are. And I'll post these slides at the end, so if you guys don't need to take pictures, you should have all this available to you later on. The second way to set some configurations through the SQL interface, there's a nice little API. You can say set key value equal to X. And here, this is an example that I'll hammer down throughout the talk, but SparkSQL shuffle partition. So when the Spark job does a shuffle, you can set the number of partitions you want to bucket that shuffle by. And this you can set right before you run a Spark SQL query, but it's very easy to set the configurations here. You can set it dynamically if you're working through the Spark shell or through a notebook interface. And if you remove the equal and the value, you can say set that key, and it'll print out what the value is for that configuration. But there's also, again, a nice way I iterate through all the configs and print that out as well. Just when I'm logging into a new system, maybe some people have been setting up their own defaults. I really need to understand what the system looks like when I'm trying to debug and help through that application. The next thing is I'll go through the Spark pipeline design, what that looks like. I'll touch upon why we want to choose efficient file formats, compression codecs, and how those help. And then Spark APIs that may not be widely known, but are helpful when you're doing machine learning. and job profiles. How do you look at a job, understand what's going on, and how do you actually try to tweak your job to improve better? So file formats. A lot of people know what CSV or JSON file formats are, but Avro and Parquet are two other file formats that are popular in this big data space. And their inherent characteristics are different between the two. Avro is a row-oriented format, but Parquet is a columnar format, which is more efficient because if you see the diagrams here, the Parquet format groups all the different the columns into a row group, and then because they are all the same data type, we can do efficient encodings of them. So we can compact them more, we can use cool techniques like bit packing if they're all inch, or strings, we can do a good compression there. So it's actually going to be more efficient to do that. And here is a story where a user had 260 gigs of CSV data. They just wrote it to Parquet and it was compressed down to 23 gigs. So if you're using a cloud provider, that is going to provide some cost savings to you. If you're using something like S3, you're not going to pay for as much storage now because you're using an efficient format. And you also get this benefit that Spark is going to be able to efficiently prune your data. With Parquet, there's offsets and there's APIs where we can say, just grab this column. I don't want to scan through the rest of the data, and it's going to be more performant. So if you're going to listen to a lot of talks, a lot of people are going to really be storing their data in Parquet format, and that's what I think most everyone should be doing here. But your file formats could come in CSV and JSON, so you might have to write a little ETL job to put it in the right format. And then compression as well. So not only do you want the right file format, you want to compress it. And so there's trade-offs there. Again, there's a cost savings as well. There's a speed efficiency as well. If you're sending over these blocks of data, if they're compressed, they're going to be sent faster. And so there's compression codecs like Snappy, gzip, and LZO, where you can compress those Parquet files. So that's going to save on cost and improve the efficiency of your jobs. And so here's a few of the configuration properties where you would need to set that up to configure those properly. So you need to set the I/O compression codecs. That's typically done in the Hadoop configuration area because you need that in your environment across all your nodes. And then if you're using the SparkSQL interface, you can specify the Parquet compression codec that you want to use when you're writing out those files. And so that's going to be helpful when you're processing those jobs. Next thing we'll talk about is these small files problems. And I've still run into this today. It's big data, but people have a ton of small files. And there's actually, it's actually detrimental because we're processing a lot of data, but if there's small files, there's an overhead of loading a lot of metadata. We still need to understand that there is a file there. We got to go get a listing from, if it's HDFS, the name node, or if it's S3, we have to say, give me all the files in this directory, right? And so having a lot of small files is not really efficient. So a lot of when you're doing this ETL process or you're working on these data sets, this also dictates how the Spark job, how many partitions are in your data frame within your Spark job, but also the efficiency of running your Spark jobs. So here you can see that in the image, I did some analysis of the files that I was writing out, and I noticed that I was writing out a lot of small files in the order of a few megabytes. And so how could I get around this when I'm writing this out in a directory? I can use coalesce that will take the number of partitions in your data frame and then merge them into a smaller number. And the number that you provide this coalesce function is going to be the number of files you're going to write out. So you can say, OK, I have this much data. I want to make it maybe 300 megabytes compressed Parquet, and I want to write it out to this directory. You're going to use coalesce, and you can write that out and dictate the number of files you're going to write out. And so this will solve the metadata loading problem and improve the efficiency of your jobs as well. So what are partitions? I think partitions is a pretty overloaded term that we use in this space. There's a few levels of partitions that you can be referring to, and this is also going to be related to how your jobs perform. Here on the right-hand side, you see an RDD. And a data frame is based off of RDDs as well, but inherently underneath, they all have this notion of a partition. And this is how the data frame or the RDD is chunked up across the executors. And this also tells you when you launch a Spark job, you might see that it's going to have 40 tasks, and that's going to be because it's reading those 40 files and is doing some operations there. So in terms of partitioning, there's this level at the Spark data level of partitions where your data set is partitioned by default, either by the number of files that you had in your system, but you can also control that with this with the coalesce or repartition APIs that I just talked about previously. And you can also find out what the number of partitions are on your data set if you're doing ad hoc analysis as well. And this is the API to do that. So there's this notion of partitions at the data level. And then there's also this, this goes into a few of those APIs that I was just mentioning. There's the repartition API and the coalesce API you can adjust the number of partitions within your data frame or RDD. And this can be related to how your machine learning jobs are going to be run on a particular data set, or even your SQL queries. And I'll show an example of a screenshot of when this kicks off and how this affects your job. And then you can repartition it here. I show an API where I call this variable df10, and I repartition that data frame into just 10 partitions. So previous slide had 40. Now I want to merge those into only 10. And this also dictates how you write out the files. And on the right-hand side, on the bottom, there's a write call where I'm saying write this data set out to Parquet and only write out 20 files. And that's why I'm doing the repartition there. And then that top right corner, we're calling a JDBC call to read in data from some SQL store. And there's, again, the number of partitions. That's how many partitions we want that data frame to be chunked into, right? And so these are all referring to that Spark partition in terms of what your data is, how your data is built out and structured in the environment. And this is under the user's control. Right? There's no intelligence in Spark to do this for you. I think that would be great to add later on, but everyone's data sets are different and how they deploy are different, so it's going to be difficult to kind of implement that and do that automatically. But this is something under your control and something you should keep in mind when you're building out these pipelines. And the next level of partitions are table-level partitions. So if you're running SparkSQL, you're going to have these tables, you have a Hive metastore. There's this other notion of partitioning by a column value. And what this does is it creates a directory per unique column value and then chunks up your data that way. So if you're querying over a table and you're constantly filtering by a particular column, say the year, and you want to only query parts of that data, instead of scanning through just an empty a single directory with all your data in it, you can partition here by that column that you're always filtering on and efficiently prune the data when you're running these jobs. So this is going to help improve the efficiency of your queries. Then there's these other things called the shuffle partitions. So when Spark does a shuffle within your jobs, there is a notion of the shuffle partition count. And by default, I believe it's 20. And here, this is another point where you can set this, and it's going to determine how many tasks are going to be launched when you're doing that shuffle, right? And so that's also related to the number of resources you have on that Spark cluster. So if you're running Yarn and you set up 5 executors with 2 cores each, you have 10 cores total, and it has to process those 600 partitions. So maybe that's too large. You can scale that down and do your job more efficiently, and so maybe improve the speed of your job. If it's a large join and you have a lot of data, maybe you're hitting some memory issues, you can increase the shuffle partitions as well to try to chunk up the data so you don't have large partitions that you're having to sort through and go through. And so, a lot of people say, my job's failing. Well, can I just increase my cluster size? Will that help my job run? And the answer is, it depends. There's some information that I don't have from the user to really know that's going to help. And everything we just talked about, the shuffle partitions, your data frame partitions, all those things are related to whether increasing the cluster size is going to help your job. Are you CPU bound? Are your tasks waiting in a queue? Is that why your job is not processing that quickly, or is there something else, right? And so, increasing the cluster could help sometimes, but for the most part, I think there are other parameters that users would have to adjust within their code, either in terms of the data frame partitions or the SQL shuffle partitions that would help improve their jobs, right? And so you have to think about, there's two aspects of it, the partitions and then how you're deploying a number of cores that you have available to process. And I think here, this two diagrams show, these two diagrams show that I'm setting the SQL shuffle partitions here, and I'm just doing a count distinct. So this is going to trigger a shuffle within the Spark DAG. And you can see here that there were 240 tasks initially, and then that 200 is the shuffle stage of my job. And then it filters down into one task to do the aggregate, to count up all the values that it was iterating through. And setting the shuffle partitions to 40 actually reduced that second stage, so it processed a little quicker. And you can see the run times were a little faster here. And this is not a huge data set, but I went from 28 seconds to 19 seconds when I was doing this test. And this was with, I believe I had 38 cores available on this particular cluster. So adjusting that shuffle partition size to my cluster size was actually helping improve a little bit of my job's performance. Now, people ask me, what's my process of how do you go into profiling my jobs? Where can I understand where the bottlenecks are? How do I make it faster? A lot of this is built into the UI, and at Databricks, we use the UI to help debug, to understand why things are slow. Maybe you can understand that you have data skew, or understand what that DAG looks like, all from the UI. And this is a picture of one of those join queries where I can go see some of those metrics about my job. I can see that there are two Parquet relations that I'm reading in. There's a filter that's occurring here, and it actually tells you the number of records that are being produced, and it helps me understand what's actually going on underneath the covers. And so the SQL UI has this nice detailed graph, and the streaming UI, if you're using Spark Streaming, has a very nice graph where you can see the number of receivers that you're using. Maybe you're only using one receiver in your streaming application when you should be using 5, and the UI would tell you that very quickly. And so that's a really nice way to understand those aspects of your job without having to drill into logs, right? The UI gives you a quick understanding of what's going on. Then there's these aggregated metrics by executors where you can see the input size and the number of records, as well as the shuffle sizes that's going on. So here in this one, I can clearly see I had a 12-node cluster, and I was reading in about 10 gigs per executor, and the shuffle size was evenly distributed. So my job's performing pretty well here. If there was a huge data skew, maybe one executor was reading 10x for that particular job, then I can go investigate and see maybe that's why my job is taking longer. And then here, this is drilling into more of a particular job within Spark, and you can go in and see the GC times for your executors or your tasks specifically. You can see the durations, as well as errors. When you're debugging these applications, your error can happen on the driver or on any one of the workers. And within the Spark UI, that error is going to bubble up, and it should be shown here. So you can kind of understand why your particular job failed by drilling into the UI. It also helps you pinpoint which executor it happened on. So you have a way to aggregate or gather your logs. You can find out which particular node that error occurred on. There's a few other things that you should be doing when you're running your Spark applications. Most of this should be set up. There's great tools called Ganglia and Graphite to help do this monitoring of Spark itself, as well as the servers that it's running on. So there's two levels that you need to monitor. You need to monitor Spark, and here's a picture from Graphite to see the number of active tasks per executor stack ranked. There's also the number of completed tasks per executor, seeing if you're efficiently using this distributed platform. You don't want to see one executor not doing anything. Maybe you have one too many, and you're really not partitioned correctly when you're running your job. And then also completed tasks per minute. So these tools you would need to set up to help monitor Spark, as well as the servers. You want to make sure your servers don't have your disks filling up, they're not garbage collecting, they're not hitting network issues. And so a lot of these have nice libraries that you can help set up and kind of debug a lot of that for you. So this just goes over a few tips and tricks when we're debugging these Spark applications. One is analyze the driver stack trace. When you're typically working, if you're working in a notebook, the driver stack trace is going to give you an error. It might say that it lost communication with some executor and give you an IP address or that host name, and then drill into that and try to find what the root cause of that error was. We don't always bubble up the errors from the executors. It's kind of hard to do that in a distributed environment. So you really need to understand what's going on in the driver, which is the main brains of your application, and as well as the workers, who are just getting the tasks and performing those. And then also review the memory usage on the nodes. You want to make sure you're not overcommitted in memory. Your JVM should not be equal to the size of the memory that's you're allocating. So if you have a container or machine, you have 30 gigs of memory, you shouldn't set your JVM heap size to 30 gigs, right? There should be some overhead, and you want to make sure that you're not garbage collecting and hitting other issues on that. On those nodes. Also disk, you want to make sure you have enough disk space to spill your data. When you're doing the shuffles and you're writing out tasks, that's going to be important, and also the networking aspect of it. A few other things when you're debugging, if you're using JDBC or ODBC, you need to have ways to test those connections to your clusters and make sure that's working. If you're using MySQL or Redshift and connecting with Tableau to Spark, having tests to just test that network connectivity is good. Having other tools to verify that it's not something wrong with your Apache Spark cluster, but maybe somewhere else in the environment. Also, when you're working with JSON, we have native APIs to kind of go through corrupt records, which is really nice. If you're doing that ETL work, there's going to be a column name to help you identify corrupt records. And I can post a link to that in the slides and update this when I post it. And then also, when you're debugging SQL issues, it's good to understand where's the data, the number of files that you have, and also the DDL, which is how you created that table. I'll skip over this just in the interest of time, but again, just make sure if you have out-of-memory issues, you're looking at all those logs. Those are typically in your logs that you're going to have. It's going to show you what those errors are. And then also, when you're running or building these applications, look at what's already provided from Spark. We have a lot of built-in functions within the PySpark implementation, where if you want to parse the date, there's a toDate function. If you want to get a JSON object that's embedded, that's there. There's this monotonically increasing ID. If you need to assign a unique number to every row, there's a function for that. You don't need to write some UDF or a wrapper to do that. So take a look at these examples. There's a link here that you can go through. But those are kind of best practices. And you don't need to reinvent the wheel when you're writing these applications. And then a few other top support issues. You can be writing new data to your table, and Spark caches the metadata for that. Sometimes if you're not getting that updated data, you might want to run a refresh table or add that to your workflow. If you're using a few other systems that are writing Parquet, there's a flag that interprets the strings as binaries. And so I was helping a customer import Parquet from another system, and I had to toggle this flag to actually read the string data because there's a different configurations there. And then lastly, as I mentioned earlier, the SparkSQL shuffle partitions. If you understand how many partitions you have and the size of your cluster, so you can do that processing, and then tune this if you're doing joins or those types of workloads. And then lastly, if you want to try any of this, we have our Databricks Community Edition that's free for everyone. Sign up, and here's the link. And thank you.
Thank you, Miklos. Thank you for the words of wisdom. I think if you follow those words of wisdom, you can really save yourself a lot of time. We've got about 3 minutes, and then we're going to break. Remember, this use case is going to be in Plaza. So if you have any questions, please use the mic and make it short. Thank you.
Hello. Hi. So do you know any tools which we can use to parse the Spark event logs to figure out the lagging tasks or anomalies in our workflow? Like we have a very huge workflow, so it's not possible to go sit around and watch each task to figure out which has queues or which has like problems. So anything where we can just load the Spark event log and which can give you all these graphs?
So you can, I don't know of a specific tool to load as a Spark event logs, but like with Graphite and Ganglia, you can get those metrics. So you can see the task execution time, and if you see an outlier, you can trigger on that and send an alert. Okay. So I would say recommend one of those systems. I don't know of something of parsing logs and doing it that way.
Okay.
I'd have to look.
Okay. Thank you.
Any other questions?
So you mentioned that you can use LZO, and LZO is basically splittable. Do you need to do index process similar to what you will have with the multi process?
So LZO, you do need to do that indexing process. If you have Parquet, where we compress, Parquet is a binary format, so we compress in these things called row groups, and so you can use that, and it's still going to be efficient. We do that. We use gzip internally with Parquet, and so it's still splittable in that sense.
Okay.
Hi, my question is around the partitions. In the previous example, we saw that if your data set is big, that for the shuffled page, you would like to increase the number of partitions.
Yeah.
But in your example, you showed that you got the better performance by reducing the number.
Yeah.
So what are the things that you should look out for either in the data set or in your Spark cluster that helps you make the decision whether to go up or down?
Yeah. So my example, I was just doing a count distinct, so it's a simple aggregate. So it doesn't need to process a lot of data, right? With a join, you would need to join two keys, and then you're bringing in all these other values, right? And so that might need more memory for those partitions. For me, I was trying to optimize for my number of cores I had available to process, and I just wanted to be a little faster. So that was an example of going down. Most likely, if you're doing it on a much larger data set, you want to go up. Yeah. I should probably clarify that, but thank you. Good question.
Yeah, I have also same question with here. See, how to handle if you're trying to decrease the number of partitions, how to handle the data skew problem?
Sorry, if you want to handle the number of partitions, what was the question?
See, in your example, you repartitions to 40, 100 to 40.
Sure.
But actually, in the previous session, it has to be increased. Then we can avoid the data skew problem.
Okay.
So in this case, data skew problem, how can we handle? But
data skew problem. How do you handle that? That's a good question. I'll have to think about that. Yeah, data skew is a difficult problem to deal with. I think we're going to release something called bucketing. I think that should help.
Bucketing works here?
Bucketing does not work yet. I know it's on the Spark roadmap, but I'd have to check. I think that should help, but yeah, I'd have to think about how to manage it today with the current frameworks.
Thank you.
Yeah.
One last question we got to wrap up.
So many times in the Yarn logs, I see that Spark executor containers are killed by Yarn.
Yes.
And then the next executor, which depends on the shuffle data, couldn't find it. And then it goes through the re-executions. It takes a lot of time to complete the job. So can you show some pointer like why this could happen?
Yeah, so there's as I mentioned earlier, you have a container, and you don't want your executor memory to kind of bounce or be set right up to that limit of that container. And when you do that and you use more memory, Yarn's going to kill that task. So what you should be doing is increasing the container size, and then I think you set the memory overhead, which actually adds some more memory to the container, and then you wouldn't run into that problem. But that's the source of the problem, right? The trying to recover and stuff, that's just, you should actually fix the root of the problem, not trying to fix the other pieces that happen afterwards.
When we analyze the log, we don't see that it has reached the initial container memory size. So let's say normally if we request, let's say 3 GB of memory, even before it reaches the 3 GB, it gets killed.
We can take that offline.
We could talk about this after, but I think that it should be reaching that limit. Like you might not be seeing it, or maybe you're not accounting for some other memory usage, right? If you're using PySpark, maybe the Python interpreter is using memory, and you're looking only at the JVM of the executor, right? So there's other things running in that container that you might not be seeing. Yeah.
Okay, thank you very much.